All right, so we're going to take a look at precipitation and gas-producing reactions. All right, precipitation reactions. So when when two ionic substances are dissolved in water, when they react, positive ions in one solution attract and bond to negative ions of the other solution. If the new compound precipitates, that means it becomes a solid and exits the water. It must be only slightly soluble in the liquid. Okay, so we've got this chart here. Take a look at this chart. So if we take bromide, let's say we take bromide, we make silver bromide. Silver bromide has low solubility. That means it will not dissolve in water. If we make lead bromide or lead chloride or lead iodide, it will not dissolve in water. If we take anything else, so we take like sodium bromide, sodium chloride, that will dissolve in water. Okay, this chart is just telling us which things will dissolve in water and which things won't dissolve in water. So we're going to be looking at this chart a lot. All right, so a precipitate is just a little solid that falls out of the liquid. It's like little particles floating in there. All right, will a precipitate form when solutions of potassium chloride and silver nitrate are combined? If you predict a precipitate will form, write a chemical equation for the reaction. Okay, so let's see. Potassium chloride. We're just going to write a kind of a skeleton reaction. We're not going to balance it all out, but potassium chloride is KCl. KCl. And K is a 1 plus and Cl is a 1 minus, so that's ionically balanced. This will be aqueous, it'll be dissolved in water. Plus silver nitrate. That's Ag, and Ag is a 1 plus, and nitrate is NO3, and that's a 1 negative. That's aqueous. Now, for this double displacement reaction to occur, what will happen? Well, we'll get the K, and we'll go with the NO3. And we'll get the Ag going with the Cl. Now, since K is 1 plus, NO3 is 1 minus, Ag is 1 plus, and Cl is 1 minus, this all works out. It's all ionically balanced. Now, what we have to do is we have to check each chemical to see if it'll precipitate. So let's look for KNO3. So we come up here. We find NO3 right here. NO3, when everything's combined with NO3, it's soluble. So it'll stay dissolved in the water. So you won't see it come out. So this will be aqueous. Now let's look at our AgCl. Cl's right here. We always start with the anion. Then we find our Ag. It's low soluble. Low soluble means it will come out of the water. That means this guy will be a solid. Here is a precipitate. Sorry, I should be showing you that. There's our precipitate. The AgCl is a solid. So, what that means, we have a precipitate reaction. So since we have this precipitate reaction, it works. We need to balance it now. This is ionically balanced, ionically balanced, ionically balanced, and ionically balanced. So all we need to do is balance it. K's are balanced, Cl's are balanced, Ag's are balanced, NO3's are balanced. It is just a 1, 1, 1, 1. Now we can use the words here to help us. When we combine potassium chloride and silver nitrate, what we're going to look for in our product side is silver chloride and potassium nitrate. So silver chloride, and we found silver chloride right here, chloride, silver chloride, and potassium nitrate we found up here. Right, so you're given two chemicals that are dissolved in water, They may do a double displacement reaction, and we want to see if one of those will be a solid and precipitate out. Right, so we're going to do a lot of examples. So you're going to need that chart. All right, so will a precipitate form when solutions of potassium sulfate and iron 3 chloride are combined? If you predict a precipitate will form, write a chemical equation for each. Well, our products should be potassium chloride, right? That's this potassium with this chloride. And our other product should be iron sulfate. We can worry about the balances later. Now we want to see if either of these will precipitate out. So we go to our chart. Right here's our chart. So we're going to start with chloride, potassium chloride. There's Cl. Is potassium up here in the low soluble section? No, it isn't. It's down here in the soluble section. So potassium chloride is going to stay dissolved aqueous. Let's look up iron sulfate. Here's sulfate right here. So we have to see if iron is in our low soluble section. No, it isn't. Iron is in our others, and it is soluble. It will stay dissolved in water. Iron was right here. Soluble means stays dissolved in water. So iron sulfate will be aqueous still. So because we don't get a precipitate in this reaction, nothing happens. This is a no reaction. All right, so this example, which of the following combinations will result in the formation of a precipitate? If you predict a precipitate will form, write a chemical equation for the reaction. We're actually going to start by writing the chemical equation for the reaction. So in this one, our Na is going to go with our NO3. So we're just going to write it roughly NaNO3. And our Pb is going to go with our S. Pb with our S. So this is sodium nitrate, and this is lead sulfide. Right? This is sulfide. So now we go to our chart. We're going to look up sodium nitrate. So you go here. Here's nitrate. Everything with nitrate is soluble. So this guy is going to be aqueous. It's going to stay soluble. Now let's look up lead sulfide. So right here is sulfide. Let's check out, is lead up here? These are the soluble guys. These are the guys that will dissolve in water. Lead is not in the ones that will dissolve in water. Lead's in the low solubility or dissolving in water one. So this is going to be a solid. This is going to be our precipitate. All right, so because we get a precipitate, now we have to balance everything. Okay, so NaNO3. So now we got to go back, balance everything. Na has a 1 plus charge. NO3 has a 1 minus charge. So this is ionically balanced. Lead. Lead has a 2 plus charge here. Where's Pb? Plumbum. Lead is multivalent. Here, NO3 has a 1 minus charge, and there's 2 of them. So this lead must have a 2 plus charge. So this lead is a 2 plus charge, and our S is a 2 minus charge. So this guy is ionically balanced. So now that we've got this guy ionically balanced and this guy's ionically balanced, now we have to balance our chemical equation. So we have 2 Nas here, we have 1 Na here, so I put a 2 in front. We have 1S, 1S, 1 Pb, 1 Pb, two NO3s, two NO3s, done. And our precipitate is this guy right here. Right, so we write out a rough version of the chemical equation, then we check our precipitate thing to see which ones, if anything, is low soluble. All right, so our second one, we got Fe with the Cl3 with the Cls and Na with the CO3s. So if this reaction is going to happen, our Fe is going to go with the CO3, that's carbonate, and our Na is going to go with the Cl, that's sodium chloride. Now let's go to that precipitate chart to see if either of these precipitate out. So we find CO3. CO3 is down here. And we look for Fe. Fe is not in the soluble with CO3. That means Fe is down here in the low solubility. That means this guy is going to be a solid. And NaCl, well, we find our chloride, and these guys are the low soluble, and sodium's not in that group, so sodium's in the all others. Sodium is soluble, it will dissolve. So this will be aqueous. So we found our precipitate, it's right here. Okay, now we have to balance this chemical reaction. To start with, we have to balance our compounds ionically. So Fe, well, that's iron. And iron can take on multiple charges. The question is, which charge does this iron have? Well, we will look over here. We know that chlorine is a 1 minus. Since there's 3 chlorines, this iron must be a 3 plus, so that's iron 3. So this iron has a 3 plus charge on it. And CO3, if I can find CO3, has a 2 minus charge on it. So this must be Fe2, CO3, 3. You can't barely see that 3 because there's a giant S in the way. Unfortunately, I did not space this out well. It's CO3, 3, and it's a solid. Sorry about that. Na is 1 plus, Cl is 1 minus, so that's ionically balanced. Now we have to do our big numbers. We have 1 Fe here, 2 Fe's here, so we need 2 there. We have 6 Cl's here, we have 1 Cl here, so we need 6 there. We have 2 Na's here, we have 6 Na's here, so we need 3 here. Now we have 3 CO3s, we have 3 CO3s. It is 2, 3, 1, 6. That's how it's balanced. And this guy here is our precipitate. All right, next one. NH4Cl and C2SO4. So let's rough out this one. So our NH4, it's ammonium, is going to go with our SO4. And our K is going to go with our Cl. So let's see if either of these will precipitate out. So we go to our chart. We look up ammonium. Do we see ammonium? NH4 on here. Right here is NH4. Basically, anything in NH4 is soluble. You take any negative thing with NH4 and it will dissolve. So this guy is going to be aqueous. No precipitate there. Then we look at KCl. Here's Cl. K is not up here, so K is in the all others, and it is soluble. So this is also going to be aqueous. So we would call this guy here a no reaction. Nothing is going to precipitate out. Okay, lastly, let's look at reactions that produce a gas. Double displacement reactions involving acids can also produce gases. So if we have sulfides and an acid, we might get hydrogen sulfide, H2S. Smells like rotten eggs. If it gets too concentrated, it kills you. Never deal with that. Carbonates. If we dissolve carbonates with acids, we often get carbon dioxides. Sulfites. With acids, we often get sulfur dioxide. All right, so what you should know is you should know this. How to figure out the precipitate of a double displacement reaction. All right, thank you for watching.